name is John Thuma. I'm with Aster Big Data COI, and I'm here with Grish Krishnamurthy, and we're going to talk about Aster physical architecture. Hey, Grish, how you doing?
Doing good, John. How are you?
I'm great. Thanks for giving me some of your time today.
No problem.
Now, why don't we go ahead and get going here? And I guess today we're going to talk about Aster and all the architecture of Aster, the queens, the workers, and we're going to take a little bit of a deep dive in here. Why don't we go ahead and get started?
Sounds good. Thank you.
Right.
I will get started. If you have any questions, just feel free to stop me. So
let's make this interactive, okay?
Yep, we will. The Aster physical architecture. So Aster comprises 3 different tiers, as you can see here: the queen nodes, the worker nodes, and the loader nodes. So the queen nodes, when I say queen node, it's a master node that coordinates the whole activity on the system. And the worker nodes are the ones that are doing the heavy lifting of the processing of data. And then the loader nodes, which is a set of nodes that speeds up your loading throughput. So these are the 3 components, or the 3 tiers, we're going to talk about. And I'll be talking about them in a little bit more detail. So here's the architecture, and as you can see, the queen node is the main node that actually coordinates or orchestrates the whole system. It actually contains the system configuration, the metadata in the system, and it actually is the interface to your query, so to your client. So it can be ACT, which is a native client that Aster provides, a command line client, or it can be any ODBC or JDBC or any client that Aster supports.
Interesting. So can I interrupt here real quick?
Sure. Yeah, go ahead.
I see these, I guess, purpose-built nodes, correct? I mean, that's what these things are, right? You get queens,
right.
Workers, and you have loading and export nodes, et cetera. Now,
right.
are they all, and we might be getting ahead of ourselves, and tell me if we are they all kind of like the same kind of hardware? I mean, what are they, servers? What are they exactly?
Yeah, these are all servers. So Aster comes in like different offerings, right? So the standard appliance offering, they actually are Dell R720XD platforms, and so these are these are all servers. To answer your question, yes, the queens, workers, and loaders and backups, but they are all not the same hardware. So they are different in certain aspects. So the queen and workers are almost similar in terms of their processing capabilities and the number of disks, disk drives in the storage subsystem. However, one difference between the queen and workers is that the queen has a higher level of redundancy in RAID. So it is more fault tolerant compared to the workers. And the reason being that is that on top of the hardware RAID, in Aster we also support the replication. So data is stored in 2 copies. So which is why the workers have a slightly lesser level of redundancy, because it's also supported at a software level. And for loaders, the loader nodes are, in terms of processing, it's the same as queen and worker, but in terms of storage, it doesn't have much of disk drives because loaders don't need to store the data. So it's mostly the workers that store the data. So that's the difference.
So one of the questions I often get from customers out there is, and they think that because I have a loader node that you're actually loading data into the loader node. That's not true, right?
That's not true. Yeah, that's a good point. So loader only helps in identifying what needs to be sent where. So your loader node acts as your gateway from your client from which you're loading into the worker nodes. So all the work data sits in the worker nodes, period. So it doesn't sit on the worker, it doesn't sit on the queen or on the loaders. So the loader helps partition the data, and it sends it to appropriate workers based on their hash partition key, which I'll be talking about in a second.
Okay, excellent. Sorry about that.
No problem. Okay, so here is the queen, and to understand like this whole, given that Aster is a MPP architecture, a distributed systems architecture, so here is how query planning takes place in a very high level in a broad scheme. So when the query comes to the queen has a global query optimizer. It essentially parses the SQL statements, pre-processes it, and hands it to the planner, which is also on the Queen, the global planner. And the global planner sitting on the Queen develops a set of subqueries to be executed, and the executor will execute the subqueries, which essentially is like pushing down those subqueries to the workers, because the workers are the ones that actually have the data, and then these are aggregated back to the Queen and then sent back to the client. So this is at a high level of how a query is actually executed in Aster.
Oh, great.
So yeah. So moving on to the worker nodes. So the worker nodes are the ones that actually store the data, and it clearly has to interact with the Queen, because the Queen tells the workers what to execute, and the worker executes them and sends it back to the Queen. The workers also interact among themselves in terms of queries where there is repartitioning of data, which I'll talk about, if not in this video, in another video, is transferring of data between the worker nodes depending on the query. And that's the interaction between the workers. The workers are all shared nothing architecture. Remember that this is MPP shared nothing, which means the workers all have the direct attached storage. They have their own memory, they have their own CPU, so nothing is shared between the workers. So in terms of what workers does, again, it runs the queries, it replicates data. So I mentioned about this workers having duplicate copies of the data for the case of high availability. So it also is responsible for replicating the data. And then there's a couple of other administrative options in case of like workers going down. You actually need to, the workers are responsible for copying, making another copy of the data, shifting the processing, etc. And then workers also remember that they have the data, which means that they host their own database. It's a local database, and the local database has its own local query optimizer. So there is this Queen, which has the global planner optimizer, and the workers also have their own database, actually databases, which have their own query optimizer.
So it's my understanding, before we jump forward, it's my understanding that the Queen also has a database in it, and it too is replicated onto one of the workers. Is that correct?
That's correct, yes. Queen has this database which does not have the actual data, but it actually has this metadata about all these, all the statements that are run, about all the workers, their positions, etc. And you're right, there is a copy of the Queen's database, which we call as QueenDB, on one of the workers. And yeah, this is again for the sake of high availability in case. So Queen has a high redundancy, so the chances of Queen going down are low. But in the event that the Queen goes down, there is a procedure to reconstruct a backup Queen. And this Queen database replica on one of the workers is used for that purpose.
Okay, thank you, sir. So here you're going to go into some V workers and whatnot. This is interesting. Tell me about that.
Sure. So the worker nodes, as I said, contains data, but again, the workers have something called as vworkers. Think of vworkers as database instances, as local database instances, and these are the ones that actually host the data. So the workers are the server nodes, and the vworkers in the workers are actually the database instances. Okay, so you may ask, like, why do I have more than one vworker per node? The reason for that is to leverage the higher level of parallelism. So the worker nodes in a MPP architecture gives you parallelism across nodes, right? Whereas vworkers within a worker gives you parallelism within a worker node, because all these new generation of hardwares come with a number of cores, CPU cores, right? So we want to leverage all these cores in processing. So by default, all these Aster appliances come up with 6 vworkers per node, and each vworker is again a database, the underlying database that stores the data.
This is something I can tune if I want to, right? I can increase or decrease the number of vworkers on my system. Is that correct?
That's true. There is a procedure for that. So by default, it comes with 6 vworkers per node. So you said do this setup at the initial time when the system is being set up. But if needed, as you add more nodes, you will have to leverage the higher number of processes or the higher number of nodes, right? In which case you readjust the number of vworkers.
Okay, excellent. And my understanding also is that the vworker is really where the data is loaded into. It's an instance of a database, but also the analytics are loaded there too. Is that correct?
So when you refer to the analytics, the analytical functions, yes, they are loaded into the database. That's correct. Yes.
Okay, correct. Excellent. So the data and the analytic functions are actually on the same system.
On the same system. That's right. Yeah.
Okay, excellent. Thank you, sir.
Yeah. Those are the vWorkers. So I also talked about replication of vWorkers for higher availability of data. So each of these vWorkers within those blue boxes, you see those orange little boxes, those are the vWorkers. So each of the vWorkers actually have a primary copy and a replica copy. So the primary copy is the one that's actively serving the queries on the system. And the replica copy is present on another node, clearly so that in the instance of a node failure, the replica gets activated automatically, and then it keeps going. So the query runs in an uninterrupted fashion. So that's the physical architecture. So when we are at the workers, I also want to talk about how the data is actually loaded into the. When I said loaded, how data actually is sent into the workers. So you talked about the loader nodes pumping data into the workers, right? So, so there is this data partitioning concept of data partitioning. So there are two types of partitioning. The physical partitioning is where you create a table, right? And then you create a table, you assign it a distribution key, and then that distribution key dictates how data needs to be spread across the different nodes. So
my understanding is that you want to spread that data out across those vWorkers and those workers so that it's got a smooth and highly distributed center, so there's no skew. Skew means that I've chosen probably the wrong distribution key and so forth. Is that correct?
That's absolutely true. So the choosing a distribution key is a very critical data modeling aspect, where you choose a distribution key such that it's not heavily skewed. Clearly, you'll need to choose a distribution key that has a high number of unique values. It doesn't have to be perfectly unique. So I can repeat, it doesn't have to be. You don't have to choose a surrogate key which is like perfectly unique, but it needs to have enough number of unique values so that when Aster hashes these distribution keys, and based on the hash value, it's going to assign these to different vWorkers. So you want to make sure that you don't fill up like two vWorkers, leaving the other 34 vWorkers empty, right? So that's the reason why you need to choose a good distribution key. And talking about choosing a distribution key, it's also important that you choose a distribution key that's used in most of the joins. So you may have an idea of the kind of workload that you're going to have in your system. So choose something for a table where that key will be used in most of the joins or group by aggregates. So the reason I say that is because you want that these activities to happen locally on the vWorker as opposed to like being transferred across vWorkers. So if you choose a distribution key which is mostly used in joins and which is mostly used in group bys, then you'll ensure that most of your workload is done locally on the vWorkers.
Excellent. Thank you.
Okay. So that's the physical partitioning or the physical distribution. And the logical partitioning is how a table is actually organized into logical partitions. So once you do the physical partitioning, so these actually complement each other. So they are not like one as opposed to the other. So you do physical partitioning so that you leverage all the space and the processing powers of the vWorkers on the system. And logical partitioning is specifically useful for large tables. And say you want to divide these tables into logical pieces, like say based on the date, say for like creating like daily logical partitions or monthly logical partitions, so that you only access that piece of the data as opposed to the whole table. So they actually complement each other. So at a high level, physical partitioning, it actually gives you the advantage of maximizing the performance by distributing it across the vWorkers, and logical partitioning further improves the performance and making the data management easier by letting you access and manage those logical data partitions. And any so let me jump into the loader nodes. So we talked about loader nodes, but essentially loader nodes are an optional set of nodes. The reason I say is optional is because in very small systems you can also use a queen to load the data. So essentially what loader is doing is, as your input data is coming from your staging system, the loader node is determining where to place the data on the workers, right? So this is the hashing scheme we talked about in the distribution key. So loader is computing for the data that's coming in, where does it need to send it to, and it hashes it and decides where to send it on the worker nodes. So, but clearly having a set of loader nodes may be very useful for systems where that demand a high level of load throughput. So I'm not, so when I say load throughput, so if you want to load like 500 gigabytes of data an hour or 1 terabyte of data an hour, so you may want to have a number of loader nodes so that it all loads in parallel. So again, loading also happens in a parallel fashion. So you can have more than one loader node so that it loads data in parallel. Whereas if you're using Queen, it's bottlenecked by Queen. It only uses one node for loading.
So the loader node actually does parallel loads into these workers, correct? I mean, it's intelligently loading data in based on some relationship with the Queen, knowing where this, is that how that works?
That's absolutely right. Yeah, that's how it works.
Okay, excellent. Thank you.
Okay, and backup nodes, even though I put the backup nodes here, the backup node actually resides on it's a separate cluster, so it's not part of the Aster database cluster, it's actually a separate cluster. And backup also reads data from your Aster system, from the workers in parallel. So that's another advantage of having this MPP system, which also has an MPP data backup system that can actually read data from workers in the case of backup, and in the case of restore, the multiple backup nodes restore back the data onto the workers in a parallel fashion. So that's from an administration standpoint. So we always recommend having a backup set of nodes in order to have like a disaster recovery.
Excellent. Thank you.
All right. So just to touch upon like these vWorkers and the replication. So as I mentioned, like these vWorkers on the worker nodes, they have a replica. As you can see, each node, the first worker 1 has a vWorker A and vWorker B. And if you notice, the replica of that vWorker A is present on worker 4, and replica of vWorker B is present on worker 3. So that in the event of worker failure, so for whatever reason, if worker 2 goes down because of some network glitch or some other reason, the active or the primary vWorkers on worker 2, that's C and D, automatically fail over to the replicas on worker 1 and worker 3. So that's a failover which is automatic. It happens with minimal performance impact, and the queries are retried so that from a user standpoint, your query is not stuck or it's not failed. So that's what I wanted to talk about at a high level. Do you have any further questions?
No, I mean, this has been excellent. Did you have any other content you wanted to go over today, or what did you have?
Yeah, so I have a couple of more things I wanted to talk about.
Let's go.
Yeah, sure. So the worker nodes, so here is a procedure to add worker nodes and scale out your cluster, right? So
can I stop you here real quick? Can
Sure.
I stop you here real quick? So what you're
Absolutely.
saying is I can add another worker if I want to. I don't have to buy I don't have to buy a new appliance or buy a new system if I want to expand it. It's really capacity on demand. Is that kind of what you're saying?
Absolutely, yeah. So you start with a set of, so you kind of plan and start with a set of worker nodes, right? And then as clearly our planning or forecasting may not be adequate like a couple of years from now, right? So as your data continues to grow, you may actually need to add more number of physical workers, right? So you just add a worker node. It can be done both in appliance or your commodity style hardware. And once that is done, so the software installation all happens in the background, and then once that is done on the worker nodes, the data actually gets pushed out to your new worker node. So when I say data gets pushed out, so that is the process of balanced data that I talked about earlier, and this is actually like a one switch or a one-click button on the management console of Aster that will actually move some of these vWorker nodes into the new worker node. So this is how it happens.
Interesting. Okay.
And this is, to add, this is all done online. So the whole process of adding nodes and then moving these vworkers, they all happen in the background. So your cluster doesn't have to be taken down at any of this time. So this is all done online while the system is online.
Zero downtime to expand a cluster system and add a new worker. Is that what you're saying?
Yeah, that's exactly what I'm saying.
Wow. Okay.
Yeah, so that's end of content in terms of like talking about physical architecture of Aster and talking about the queen, workers, and loaders.
Okay, great. Thanks, Girish. I really appreciate your time, and thanks very much.